Welcome everybody. Welcome to this SCF webinar, another in our series. Now today we're going to be looking at the evolution of a very important component of the small cell ecosystem, the FAPI interface. And this is really a status update meeting for actually a number of the contributors of the technical work within the forum are attending today. You can see their names here, and they will be introducing themselves as we go through the presentation today. Next slide, please. Just to say before we go much further into the content that there is the opportunity for you to interact with the presenters via the Q&A tab at the bottom of the screen. So if you file your questions in there, and we will treat those questions as we get towards the end of the webinar at the end of the hour. Really, we're going to take you through some of the critical aspects as we see it in terms of the FAPI interface, which has been worked on for a number of years within the forum. It's really for us a very important component of the ecosystem. It helps us to unambiguously define a particular interface in the and the sort of API type interface definition, which is used for us for the from a development perspective in terms of new product, chip and mobile product, but also we use it very much as a way in which to analyze the features that are emerging from 3GPP and the O-RAN ecosystem and looking at the O-RAN alliance. It allows us to think about O&M support as well, and the forum expertise and the contributors to the FAPI specification are quite detailed experts in the PHY MAC area and mapping that functionality and ensuring that it's a solid interface that could be used in product development. And now the goals of FAPI have always been from the start to encourage commoditization and competition on the interface, innovation in an appropriate way there, reducing barriers to entry, so this commoditization agenda that the forum has, especially in the context of small cell deployments. It's always important to get the right price point to make the total cost of ownership work for the network, and we're constantly looking at how to make that happen in the product ecosystem. And importantly, in terms of the agenda around cost and making sure that we're commoditizing in the right way, trying to minimize the amount of custom engineering that's required at this quite detailed interface in the system. So there are a number of contributors to the specification, and some of whom are going to be presenting to you today, and you'll see and hear from them in terms of the key features. But we're wanting to make sure that FAPI is very much flexible enough to address the emerging use cases in the 5G era, so to speak. So we've got, of course, the mobile broadband, but there are also important areas in system capability now emerging around ultra reliable and low latency IoT related functionality, and thinking not just about indoor but also outdoor deployments. So next slide, please. Here I'm going to start handing over to Andrei, but let me just say first of all that for those a broader context, in the early stages of 5G there was a great deal of discussion in the standards bodies about how to disaggregate the deployment of the systems and the interfaces, and we've identified that this FAPI specification is highly relevant across a number of the different splits of the standard. For those of you who have tuned in before on the SCF webinars, you would have heard about the DARTS tool, which helps us to do some detailed analysis. But today we're going to be focused on the specification itself of FAPI. And I'm now going to hand over to the chair of the FAPI working group, Andrei, who's going to take you through the next stage of the presentation.
Thank you, Simon. So this is a perfect kind of slide. It shows both the breadth of architectures that are supported by the suite of FAPI specifications, and also the level to which the specifications apply or drive each of the types of architecture. So underlying all this architecture support is the FAPI, what's known as the FAPI 5 specification, SCF 222. You can see there at the top, which define the interface between layer 2 and the Hi-Fi baseband. So that's common to all these architectures. But in addition, to make sure that there's comprehensive support for each, there are additional FAPI specifications that derive those particular areas of focus. So for instance, for distributed small cells, as well as for split 2, you would want a network module. So that's SCF 224, still FAPI specifications. You might be, you also would need to be able to drive the front hole. So that's P19, SCF 223. And for the small cell part, you are also covered by the MVP specification that Martin will cover later on, SCF 251. For the split 2 and split 7-2 architectures, mostly focusing on macro and massive MIMO deployments. Then you have the MIMO driver as a topic covering multiple areas, as well as 3GPP advanced features that apply to this particular type of deployments. Those are the main drivers for these kind of architectures. Then 7.2, I mean, the most known group, obviously ORAN, is going to drive a lot of the features. And part of that, you also need an M-plane. So SCF 229 covers M-plane. And to close the loop, then you have split 6 at the bottom. That one is driven through the SCF 225 specification and FAPI. And based on FAPI, there's also a test setup specification, SCF 228. So in practice, all these specifications apply to all these architectures, but specific architectures are used to drive the specifications in such a way that the specification is always sort of at the cutting edge of that particular architecture and also covering the needs of the other architectures. Next slide, please. So this is a very succinct map that shows the evolution of some of the FAPI specifications. Not all of them are listed here, only the internal FAPI specifications are listed here. So you can see going from left to right, the advance in time from 2020 when we started with the 5G FAPI up to today. And then on the vertical axis, as you can see with different colors, different specifications. From the top, FAPI PHY, basically the SCF 222 specification. Then for in the blue being the FAPI front end, that's P19. Then you've got the FAPI network module, that's P4, in kind of dark blue. And then violet at the bottom, you've got the OEM FAPI OEM specification, that's P9. So there is a pretty high high depth to each of the specifications. I'm only listing here the main parts. So you can see here the main drivers for each of the specifications, such as MIMO driving most of the baseband, evolution, ORAN, front hole kind of slowly being added starting SCF, starting 2020. Then you can see the 3GPP evolution, percolating through all of it, starting from release 15 in 2020, going through various release 16 features. And I will cover that in a future slide. P19, similarly, you can see the various evolutions and drivers. It's a specification that has reached a certain level of stability. You can see that towards the end. P4 has seen a recent uptick, as you can see here in 2023 and 2024. And P9 has been identified as a quite needy specification to drive the ORAN integration. Next slide, please. So to look at some of the drivers, the 3GPP obviously is one of the main drivers. Everything is driven by the member contributions and member requests, but release 15 is a very comprehensively covered and stable baseline. And from release 16, we've picked features that are of interest to members that implement the specifications and are aware of the market needs. So you can see there the work items that have been addressed in order of time. So remote interference mitigation being the most recently addressed one in part of FAPI V8. In ORAN, we have pretty much integrated support for control, user plane, and synchronization plane, as well as added support for virtual functions with a lot of details, mostly shared in SCF 222. And a key driver of many specifications, but in particular the ones that pertain to SPID 7.2 and SPID 2, is MIMO in its kind of massive MIMO incarnation or enhanced MIMO incarnation. Or enhanced MIMO kind of refers to this GPP work item, what is massive MIMO is the generally understood feature. And that one has been driving a lot of features all throughout the specifications up to FAPI V8 and also the ongoing FAPI V9. And that leverages both aspects from ORAN, as well as aspects from the GPP, as well as aspects that are specific to FAPI that are not captured by this group. So now to cover the SPID 6 support, I will hand off to Ganesh, who is the FAPI rapporteur, also from Radisys. Thank you.
Thank you, Andrei. This is Ganesh Environment from Radisys. I co-lead the 5G and FAPI work item. So there is a strong connection between the FAPI, which is the network layer, the network FAPI, which transparently carries all the FAPI messages, and that's how it was originally designed in 4G or the LTE days, and then we have extended that framework, or we have made that framework very comprehensive to make sure in case of 5G we carry all these messages, P5, P7, P19, and of course the P4 messages as well. So you will see a very tight interlinking of the specifications and the messages defined in the underlying FAPI specifications and how they are carried into FAPI in a seamless fashion. So FAPI as a framework has been streamlined and made very comprehensive in 5G. And we also defined the transport options for carrying these messages. And of course, we use different types of protocols, connection-oriented and connectionless protocols to carry these different type of messages in control and data plane. And the key FAPI features, there is a concept of PNF and CNF or VNF, and this was originally defined in 4G days. And this allows us to interact between the two entities, the layer 2 on the one side and the PHY layer on the other side, how they interact, the virtualized entities and the non-virtualized other PNF entities, how they interact, and the required levels of state machine definition, including the aspects of how to synchronize between these two entities, which are disaggregated and connected over via a FAPI front haul, delay management and other aspects. So all of these have been defined, and what we are doing as we evolve the FAPI evolution is a little slower than the FAPI. The FAPI updates are coming much faster because of the 3GPP and ORAN alignment, and FAPI being the basic framework network wrapper you don't see as many updates in the NFAPI specification, but we are trying to make sure that the NFAPI and FAPI definitions and the specifications are in tight sync, including the message payloads and the headers and so on. So that is the level of alignment we are achieving between these two streams, between FAPI and NFAPI. And we are also making sure that this is easier for adoption and multiple implementations, whether it is FAPI based or NFAPI based. And you will see open source implementations also adopting this framework. And as FAPI evolves, NFAPI will also evolve, and vice versa. If there's a particular significant update of NFAPI that requires any update in FAPI side, we want to ensure that. And the last thing I want to highlight here is that we are also studying this aspect of a non-ideal fronthaul, which is an ongoing study item, and if there are contributions that are welcome, to study the different transport options, which are less than ideal to carry the NFAPI packets for any transport available. So that's the quick summary of NFAPI work and evolution. I would now pass it back to Martin from Picocom to talk about the FAPI features. Thank you.
Hello, thanks, Ganesh. So hi, I'm Martin from Picocom, based here in the UK. Picocom has been contributing to the FAPI specification suite for around about 5 years now, with a focus on small cell support. So I'll talk about a few activities that have been ongoing in addition to the core SCF 222 FAPI development. So next slide, please. So a couple of activities on this slide. We have the P19 FEU, which stands for Front End Unit. So these are enhancements to the FAPI specifications that allow layer 2 and layer 1 to extend their control into the analog functionality in the front end of a radio subsystem. This activity has been going on for a number of years and is largely stable. We've had some maintenance, some protocols and some small tweaks to the specification in the last year or so. Another activity quite important for small cells is network monitor mode, so FAPI P4. And this is about supporting multi-radio access technology network monitoring. The applicability of this function has a number of applicable areas, but one particularly key area is shared access license deployments. So, for example, in the UK, we have spectrum from 3.8 to 4.2 gigahertz, where network monitor mode is an important function that allows spectrum to be shared. So in the last year or so, we've enhanced the protocol specifically to make the protocol more performant. And we've also better aligned with, or rather, we've extended the alignment across 3GPP functionality. Next slide, please. And then we have a couple of study papers. So these are not specifications or part of the FAPI suite, but these are developed in parallel with FAPI, and they are quite useful as background reading in providing context for why FAPI is important. So we have a couple of papers, SCF 251, which looks at what an FR1 small cell might look like, primarily from a hardware point of view. And just a couple of months ago, we finished off an activity, SCF 253, which extends that analysis to FR2 5G millimeter wave. And we can see on the diagram below, we have a number of hardware components, and then we have interfaces and flows through that hardware. And annotated on that diagram, we've got the FAPI P5, P7, and P4 specifications running between L2 and L1. And then we have P19, which is extended into the RF subsystem. So with that done, I will hand over to Jerry from Mavenir, please.
Next slide, please. Next slide. Hello, everyone. So I'm Giri from Mavenir. So today I'll be presenting two proposals from Mavenir. So first one is being OCNG, and that stands for orthogonal cover code noise generator. So this is the proposal coming from 3GPP, which we have proposed in SCF FAPI. So the intention of this proposal is to create artificial noise or interference from L2 to L1 with the help of orthogonal cover codes, so that it doesn't interfere with the desired or actual load. So the overall use case for the operator here is that, okay, he can test the interference and noise in the cell or neighboring cell, etc. So very effectively. So, and next use case is he can load the network, because in maintenance window, etc., there can be very less traffic, and then he can really load other unused PRBs with the noise and interference, and then see how the network performs under high traffic condition. So that can help the operator to enhance the robustness and reliability of the equipment. So also another use case is that, okay, he can keep under watch the parameters like interference and noise, whether the equipment is really handling these statistics and then measurements properly or not. So next slide, please. So for this, there is no special handling that is required at PHY, but the DLTTI request that the L2 is arming towards PHY for every TTI. So the new PDU is being added, which is called OCNG PDU. So there, the configuration related to OCNG, like a symbol, start symbol, etc., all these are signal to PHY, and then PHY can generate the OCNG waveform. So this is the first proposal that the Mavenir has proposed. Next slide, please. So next proposal was about the subband reporting. So upper layers of video, they can benefit from subband metrics like noise and interference and signal power as two separate metrics, and this would help in accurate power control and link adaptation algorithms, etc. So today the subband reports are not in immediate usage form, because these are not separated out. So the proposal is based on two approaches. One is SRS based, another is non-SRS based. Where SRS is not available, we can go for non-SRS based solution. So in the SRS based solution, the L1 will report to L2 per PRG level RSRP, and the N plus I, which stands for noise and interference, separately, and this is iterated for all the PRGs that are configured. So in the non-SRS space, wherein SRS is unavailable, then the proposal goes in two phases. One is L2 signaling to L1 using new metrics request. So he asks for gives the list of PRBs which are not allocated, and L1 to L2 in reply, when the data is arrived at L1, the L1 will send the UL metrics indication message, and that will have per PRB level RSSI for both allocated and unallocated PRBs. So these two proposals what we made in previous version. Thank you. You can go for next slide, please. Marvell.
I'm from Marvell, and as Marvell has a solution of a hardware accelerated layer solution, also which also complies with the FAPI 222 MAC5 interface. But the next slide, please. So the latest version of the FAPI has undergone the changes which make the data structure more suitable for the layer 1 ASIC modules. As most of the ASIC works with the data in fixed chunks, which we usually call as words, which can be of 16-bit, 32-bit, or 64-bit, or even in some cases 128-bit byte in some cases. FAPI does support all the entire range of the word sizes up to 128-bit. And with the latest FAPI 222, almost all the table has went under a detailed scrutiny to eliminate the misaligned data, and which can lead to extra processing steps for any ASIC. In particularly, if one can notice, the changes has been made in the random access related data structures, rate matching data structures, MIMO related data structures, where all the misaligned data, possible of the misaligned data, has been eliminated completely. FAPI accomplished this while maintaining the full backward compatibility with the previous versions. And that is sometimes becomes much more challenging for us while the development of this different specification, because another mandatory guideline from the FAPI is to keep it simple, functional, yet factual. So FAPI is OEM friendly. FAPI is definitely ASIC friendly. Next slide. With this, I would like to hand over to Simon to take you guys through the evolution of FAPI.
Thank you, gentlemen. So we've had a fairly whistle-stop tour around some of the features, and in particular, you've been hearing from the members who've been engaged in the specification work, and I think it hopefully is clear to all the attendees that what you're seeing here is not just the detail of an individual specification that defines the interface, but also a family of specifications, as was shown very nicely by Andrei on his slide, giving us a view as to how the interface could be used in particular applications. So it's a quite involved activity now to evolve the specification. And one of the key areas that we're quite keen on doing within the membership of the forum is fielding questions or ideas regarding the feature set and how it could evolve. There'll be a feature packaging conversation that happens within the forum over the next couple of months as we start to look towards the next releases of the specification. Next slide, please. Now, before I open up the forum and get the panelists back in, I guess it's worth us just highlighting here the sort of areas that we'll be deliberating on. The FAPI specification has always been driven by the 3GPP activities, and we always try to be running in lockstep with the releases there as much as possible and compliant with 3GPP. But as ORAN, the Open RAN and the ORAN Alliance has grown in significance and importance, now we can see some features there that are also of great interest. And a few months ago, the SCF and ORAN Alliance re-cemented our strategic partnership and continue to exchange views in terms of the evolution of the ORAN Alliance specifications and how the FAPI activities fit into that and complement that activity. So there's always a debate in forward-looking conversations about the releases about where do we place the emphasis in this particular release? Do we focus on 3GPP? Do we focus on O-RAN? Do we have a balance view? And each member will have a view depending on their development efforts. There is a wider collaboration actually that happens with the Open RAN ecosystem as different use cases emerge. We're certainly getting a strong signal from the market now that Open RAN and the small cell multi-purpose like network deployments are ideally placed to try out some of the more advanced features at perhaps a low cost point than thinking about a full national network deployment of a macro network. There are plenty of things that can be done and enhanced within feature sets of city scale or campus scale networks that would typically use smaller cell platforms. So we have the features driven by the members, which is important as a feature of the way in which we work collaboratively within the forum. However, we are always welcoming input from non-members. It hopefully is clear that if you want to have a direct input into the writing of and the steering of the packaging of the features, then you need to be a member. But we're more than happy to take input from the wider ecosystem, and there's an email address that you can use to send inquiries or any follow-up detailed conversation pieces you'd like to have with the FAPI working group at info@smallcellforum.org. So what we're going to do is we're just going to open up to the panel. I'm seeing a few questions coming in on the chat, so I think we should probably just pick those up because some of them are detailed about the recent, just the slides that have been presented already, and we should just probably mop up those first, gentlemen, before we move into a more general discussion about the next set of features that may come along in the FAPI pipeline. So is everyone on screen? I can see everyone is appearing. Excellent. I've got a question which I'm just going to field. I think it's going to have to go to Yuri. And actually, it looks like, Yuri, you may have already answered this, but let me just, for the benefit of the audience, pick up this question that's come in. It's relating to your slide on OCNG. You may or may not wish to have that slide back up, but if you do wish to do so, I'm sure we can ask for that. But this is related to that OCNG slide. If the OCNG is orthogonal and does not interfere with the desired signal, what is it supposed to interfere with, is the question that's being asked. So, Yuri, are you online able to chip in on that one?
Yeah, so I have answered in the chat room that, okay, it can help in the native cell, wherein we can study the impact of the load, and secondly, the interference and noise impact to the neighboring nodes. So without really having to have the true load in the cells.
If
Thank you.
I
Andrei,
can
Andrei, do you like to comment on that one? Yeah.
Yes. So the O in OCNG refers to the orthogonal waveform orthogonality. So within the same cell, you have the ability to generate load that doesn't interfere with your own cells, waveforms, or sensor locations, but it would be able to interfere with surrounding cells, so generate load over surrounding cells. So when you have this OCNG feature turned on, just like Gary was saying, you can sort of see how the network behaves under different load conditions on cells where you don't have interference inside the cell necessarily, but you have this load across cells being visible from one to the other.
Yeah. And there's a number of use cases for that feature that were picked out in the slide. Not least of which I guess is there's obviously important capabilities there around interference testing and load simulation. But I think the feature or the benefit of having it for equipment validation is also useful as well around the GenoB equipment validation. So that there's a number of use cases there for that feature. Looks quite useful. Okay, hopefully that's Andrei. Hopefully that's answered your question. I see another question that's coming here from Jeram. Apologies for the pronunciation if that's not correct. Now this is let's see who we think would be the best to answer this. Anshuman maybe, or Martin perhaps. So in the case of non-SRS based, using unused resource blocks for estimation, how does it align with ORAN's 7.2 split on the CU plane? This is a nice question where you start to pick up the alignment with the ORAN 7.2 split, which only uses resource blocks are possible which are sent between RU and DU L1. So this is quite a detailed question, technical question. Hopefully somebody feels confident to be able to answer that one online. That would be good. Anshuman, I see you've chipped in with an answer there. Are you happy to speak to that?
Yeah. So for the first part of the question, whether the unused RV for estimation, yes, we have a field, and the field in the UL metric, we have the field of any unallocated PRB-V8, and along with that, another field is unallocated PRB bitmap is there. So we do have the first field. For the ORAN part, I think Andrei would be the best person to answer this particular question. Over to you, Andrei.
Thank you. So there's practically from ORAN perspective, there's no requirement as to which IQ sample, which RB's IQ samples are extracted or not. That's really a choice of the ODU. So it becomes effective if you use this feature and you do want to observe metrics that occur in RBs that are not allocated to specific TGPP channels. There's nothing that prevents an ODU to ask the ORU to provide those IQ samples. So yeah, it would be extra IQ samples, but they are for a good cause. So as Anshuman explained, we can identify what those samples are in FAPI, and layer 1 has all the information it needs to ask for them.
Okay, lovely. Thank you very much. We've got a question coming in from Haluk. Okay, this is a more general question. It's more about market scale. I don't have the figures at the top of my head, unfortunately, Haluk, but I would recommend that you look at the market forecast report that the SCF publishes each year. There will be a report published in the next month or so. Perhaps actually, I'm thinking it's mostly for members for a couple of months, but it will be published. It will be more widely published towards Q3 of this year. So the answer is that there's the joke or the comment that always comes to the forum is, when is the year of the small cell? Well, we see steady growth in penetration. The markets that are looking quite interesting for the SCF, neutral hosts are very much leveraging the small cell platforms in their networks now. Private networks are ideal targets for small cell platforms. There's a growth for sure in the millimeter wave area. We're seeing a number of millimeter wave products in the sort of industry 4.0 sector. Again, small cell platforms. So it's quite a diverse market, and it's not purely a public mobile network operator addressable market. It's much broader than that. The FAPI, yeah, I mean, the fact that we have a number of companies here contributing to the specification would hopefully give you confidence that FAPI is being utilized. I don't know whether anyone wants to speak to that point in terms of the utilization of FAPI in the market, but I'm looking for hands from anyone on the panel who'd be happy to pick that one up. But yeah, I think that certainly 5G FAPI is being adopted for sure. Andrei, speaking from a Qualcomm perspective, I don't know any of you who went to some of the stands at Mobile World Congress will have seen, not just on the Qualcomm stand but on other stands who are SCF members, products that utilize chips that utilize FAPI for the internal interfaces of development platforms. So it's quite widely used now. Anyone want to add a complementary comment to that, or add on top of that, or we can move on to a general discussion? Oh, sorry, there's another question that's come in, so we'll have to address that first. But anyone want to comment on FAPI utilization in general?
I mean, from a software vendor point of view, Radisys supplies software layer 2 and above. So we've seen a broader adoption right from the start of the 5G FAPI definition, broad adoption of 5G FAPI, and examples of FAPI adoption as well. So it is more uniform and consistent, even better adoption compared to even 4G days, is what I would say.
Okay. What I'm seeing now, thank you very much, Ganesh. That's useful. So yes, that's a very good point. Actually, the software vendor ecosystem. You mustn't forget that there's the really interesting point about the SCF is we have guys who are developing chips, and we have the sort of embedded software expertise as well, and they converge at this point in quite this is a high performance part of the product in the baseband. You can imagine it needs to be reasonably well engineered embedded system like engineering. Now I see a follow-on question which we may or may not we may lose the thread here if we don't remember the context of the question that was asked a little bit ago. So just to remind ourselves that we had a question about non-SRS based activities and the ORAN 7.cu split. And then Jairam has come back with a comment, which I think in effect is confirming what was said. So in effect, that feature is a trade-off between the front haul bandwidth versus the additional feature. Is his interpretation of what was being said by the team in response to his question. That may be a fair summary. Andrei, do you want to comment on that? Was fair enough?
I mean, every time you add a feature that needs observation or transmission over the interface, the trade-off between having that feature and saving the front haul. Ultimately, the goal is not to save the front haul. The goal is to use the front haul in order to add value. So that's, yes, it's basically, as long as the feature adding a value, then the front haul is worth it. Yep,
absolutely. Thank you. Right, so now quickly jumping in before we get any more questions that distract us from our next stage of the conversation. So I sort of set the scene by saying, we're now at the point where we've made some statements in terms of the features that are in the current release of the specification, and now we all go through a process within the forum, and to some extent, we're opening up some of the internal conversation.